Hi guys, welcome to a short video series just summarizing the topic of trigonometry. It's not a deep dive, we won't go too deep into the concepts, but this will be just a review of how to do the different parts of trigonometry that we need as prescribed by the syllabus and the curriculum. So for deep dives, we will do some other videos, and for my classes we go deeper into it, some of the history and some of the other applications. So this is not that kind of video. This series just focuses on getting the basics right. So let's just dive into it. First one is the basics of trigonometry, the basic three ratios. If we have a right angle triangle, then we're working from this angle theta, then we have our three basic ratios. We've got the sine of angle theta, we've got the cosine of angle theta, and we've got the tan or the tangent of angle theta. So the sine of angle theta, that is the ratio of the opposite side to the hypotenuse. So that is the opposite divided by the hypotenuse. Sorry if it takes a little bit of time. I'm changing colors just so it helps us going forward. Then the cosine of an angle, that's the ratio of the adjacent to the hypotenuse. So that is adjacent over hypotenuse over hypotenuse. And our tangent, that is the opposite side divided by the adjacent side. So that is our ratio for tan. So these are the basic building blocks of trigonometry. Now trigonometry actually has more to do with circles than with triangles in some way, but we're going to accept that this is the basis we're working from for now. We'll get into, once we get, as you can see here, this will be part of the next video. Once we get to the circle and the cos diagram, we'll see how circles influence trigonometry. Okay, so for this first one, we're just going to look at the four basic kind of questions we can get asked in this chapter, assuming we've got right angle triangles. Later on we'll work with the non-right angle triangles. Okay, so we've got four example questions here. Question one, we have to calculate x, right, the unknown. So what do we have? We've got an angle, we've got a side, and we're looking for another side. So our angle, we've got adjacent, and we're looking for hypotenuse. So which ratio has adjacent and hypotenuse? That'll be the cosine, this boy here. So let's see. Our basic equation would be the cosine of our angle is equal to the adjacent divided by the hypotenuse. So divided by the hypotenuse. Alright, now we just need to solve for x. So we get back to our algebra that we learned throughout the previous couple of years. How do we get x by itself? Well, getting rid of a fraction, we can multiply both sides by the denominator, which will give us x cos 60. I'm just going to write everything in pink now, that's fine. X cos 60 equals 5. And then we're going to divide both sides by cos 60 to get x by itself. So x equals 5 divided by cos 60. This you can type on your calculator, and you will get x equals 5 divided by cos 60 should give us 10. So x equals 10. Good. Let's try question number 2. Question number 2. So here we have, we've got an angle and we've got two sides. Which two sides? Opposite and adjacent. So which one are we going to use? The tangent. Right? The tangent of this angle, tan of angle theta, in this case the angle is unknown, is equal to the opposite. And I'm just going to do the first step in colors again. Opposite over adjacent. Opposite over adjacent. Alright. And now, what do we do now? Because the thing is, we want to get theta by itself, but what we cannot do, and please pay attention to this because this is a common error, we cannot do this. Divide both sides by tan. Sorry, not by tan theta. We cannot divide both sides by tan and cancel that out. Because tan by itself means nothing. Tan is a ratio, it's a function. It's like saying we're dividing by multiply, or we're dividing by divide, or dividing by addition. It doesn't make sense. You'll see the same with logarithms. You can't divide by a log or multiply a log in, because this just means tan is not a number or a thing. It's a function that we're doing on this angle. Okay, so what we need here is we need the arctan, the inverse in a sense of tan, working backwards. So to do that, we're going to say our angle is equal to the arctan, or as we refer to it in high school a lot of times, shift tan or second function tan of, and then we just put our number in. So once we have a single ratio, like tan or sin or cos equals a number, then we can just do the angle equals arctan of the number. And this one will give us 45 degrees. Good, so that is our angle theta. Right, moving on to the third type of question. So the first one was finding a side when given an angle and a side. The second one is finding an angle when given two sides. This third one, what's happening here? Well, we have no angles. The 90 doesn't count because we're assuming right angle triangles already. But we have three sides, all of them unknown though. But what can we remember about right angle triangle and sides? That's right, we can use the old Pythagorean Theorem. So we can say that theorem says the short side squared plus the other short side squared equals the long side or the hypotenuse squared. So let's do that. So let's say this side squared, x minus 1 squared, plus the other short side squared, which is x squared, equals the hypotenuse squared or the long side squared. Right, so here we see we just multiply everything out and solve for x. Right, let's do that. So multiplying out this bracket, and again another clue here, or a tip rather, this is not x squared minus 1 squared. That would be wrong, because what does squaring mean? Multiplying by itself. So it would mean x minus 1 times x minus 1, and you multiply this out. FOIL method or however else you usually do it. So I'm going to step that step and just multiply it out of my head. So we'll get x squared minus 2x plus 1 for that part. This part is just x squared, and the same here, x squared plus 2x plus 1. Alright, so since this is a quadratic trinomial, we want to get everything on one side equal to 0, because that's how we solve quadratics. And yeah, I don't actually like saying because that's how we solve quadratics, because there's a lot of nice things that go into it, and understanding it is a lot better than just saying, well, that's the accepted method. But again, this is not the scope of this video or this video series. So let's collect. X squared plus x squared is 2x squared, and we take that one over minus x squared, so we just get x squared. So now we've covered all the x squared terms. Then we look at the x terms. Negative 2x minus another 2x is minus 4x, so we've covered all the x terms. And then the numbers, 1 minus 1 is nothing, so we can ignore that, equal to 0. And solving for x in this case, we can factor out an x. We're left with x minus 4 equals 0. And this will mean, since we've got two things multiplied together and the answer is 0, that means that one of these things must be 0 for the answer to be 0, right? Because 0 times anything is 0. Okay, so either x equals 0 or x minus 4 equals 0. So this one is solved. Here we can still take the 4 over, or add 4 to both sides, probably a better way to think about it, and we get x equals 4. So now we just have to test, do both of these work, or can we eliminate one of them? If we look at our picture, what do these values represent? They represent distances or lengths of lines. So let's take this for instance, x minus 1. If x minus 1, if we substitute 0 in, if x was 0, then this length, this distance would be negative 1. And that doesn't make sense. We cannot have a distance that's negative, right? That means shorter than no distance at all. That's impossible. So our answer would be x equals 4. And we can just quickly verify that. Let me just do the verification in another color. If we have x minus 3, I'm just going to draw a quick triangle here. So 4 minus 1 would be 3, 4, and 4 plus 1 would be 5. Does that work? We know that's the most famous Pythagorean triplet, and we can just verify by saying 3 squared, oh that's an ugly square, 3 squared plus 4 squared, what does that give us? 9 plus 16, that gives us 25, and what we said, if this is a true Pythagorean triplet, it must be equal to the hypotenuse squared. So 5 squared equals 25. Yes, they are equal, so this works. Our solution was correct. Alright, so that is Pythagorean Theorem. That's also something that's included in the chapter on trigonometry because of its relation to right angle triangles. Right, so you have to be able to do that. Don't think you have to use sin, cos, or tan. It might be that you are looking at a Pythagorean question. Alright, last question for this video. In this case, we've got two angles but no sides. So again, if that's the case, we probably won't be using sin, cos, or tan, because sine, cos, and tan, as we can see here, they're a combination of angles and sides. You either want one of them and have the other two, or that kind of combination. But in this case, we are not interested in a side, and we don't have any sides. So sides are not even part of the equation. But what else do we know about triangles? We know all the angles inside add up to 180. Now we already have the 1. So that's what we're going to use. We're going to say 180 must be the sum of all the angles. So the one angle is 90, another one is theta, and another one is 2 theta. Now we just solve for theta. So minus 90 from both sides, and we get 90 equals, and theta plus 2 theta gives us 3 thetas. And if we divide that by 3, we'll get 30 degrees equals theta, and that's our final answer. So again, just another thing, we don't have to use sine, cos, or tan if there's not enough information. We can use other things that we know from past experience or past learning. And in this case, that the sum of angles in a triangle is 180 degrees. Alright, so this video was actually slightly longer than I intended, but I hope we laid the groundwork quite well for the basic idea of finding a side by using the trig ratios, finding an angle using the trig ratios, and then Pythagorean Theorem, and sum of angles in a triangle. Alright, in our next video, we'll be looking at the rotation of angles throughout a circle, and see the implications thereof for graphs, and the repetition thereof for general solutions. A couple of things we'll look at that. In the famous cast diagram, it'll be the introduction to that. So join me again for the next video.